I'm gonna cover some extra concepts because your quiz is gonna have a few extra questions on conceptual stuff. So I wanna make sure to address some of those as I go over this as well. So the first thing you wanna do, this first question, you have to understand vocabulary. So when they talk about troughs, when they talk about crests or nodes and antinodes, you need to know what that is in order to draw it accurately. One common mistake I saw with students is that when it said it started at a trough and ended at a trough, they included kind of this upward motion of the graph to equilibrium. If it says it starts at a trough, you literally have to start it at the middle of your minimum trough position. Okay, so you don't include any of this part. And then you've got a trough in the middle, and then a trough again at the end. Again, you don't want to include that upward motion of your transverse wave, because then you're going to add that to your distance, which you don't want to do. So this distance is 4.5. This equation is not in your physics helper, so I want to make sure that you understand in order to find a wavelength, you have to know how many waves are within this 4.5 distance. So I've got 4.5 meters. The distance here for one wavelength, and I know a lot of you are used to counting it from equilibrium, up, down, and back to equilibrium. If I started a trough, one full cycle ends at a what? Trough. So trough to trough is 1, trough to trough is 2. So I've got 2 wavelengths in this 4.5 meter distance. So basically you take your 4.5 divided by 2 waves and get your 2.25 meters. So this is not an equation in your physics helper, but basically your wavelength is the total distance divided by the number of waves. It should be a concept that if you draw it out correctly, you're able to conceptualize, understand. So you don't necessarily, the units of this doesn't necessarily matter. Most of the time I have you take whatever unit, centimeters, millimeters, and convert it to meters, but when we're working with waves, if you have it in inches or centimeters or feet, you can leave it that way as long as it just translates to your final answer when you do your velocity. Okay, so this is how you find a wavelength visually by drawing it out. Part B is to find the period. Now the period, by definition, capital T represents period. Again, wavelength, this lambda, I need you to memorize, that's wavelength. But capital T represents the time per wave. So period is obviously a time in seconds. If you're trying to find the period, you have to put the amount of time it takes for whatever number of waves you have passing, and when you do that division, you have the time for one wave. The frequency is the inverse of that. How frequent that wave, or that cycle, or that event happens. So it's number of waves over time. And that time is 1 second. So if you divide the number of waves, which is 5.5, or sorry, the number of waves, which is 4, divided by the number of time, then you would get the amount of waves in 1 second. Does that make sense? So a lot of students like to do the frequency first, and I saw that happen a lot. They calculated 4 waves over 5.5 seconds, and that value was 0.72. Unit is in hertz. This is not your final answer, but in your physics helper, you have the equation that frequency is equal to 1 over period, Or if you rewrite it, period is equal to 1 over frequency. So for those of you who wanted to start with frequency first, you could take 1 over the 0.72 hertz, and that would equal your 1.375. But what's my unit? You need to include your units if you want full credit. Oh, I see. Oh, that is a second, right? 1.37 seconds, sorry. Include your units the way this student did in seconds. Any questions on B? Okay, last question is using the velocity or speed of a wave equation from your physics helper, which is wavelength times frequency. Remember, your wavelength is not your total distance of 4.5, and I saw some students do that. It is just one wave. So your wavelength is your 2.25, and your frequency is the frequency that we got from taking our number of waves divided by our time. So 0.72, multiply that together. What should my units be here? Meters per second. It's a speed value. Meters per second is your speed. Any questions? Okay, there's going to be some questions on proportions. So I want to make sure, because we just did our review test and proportions was the most commonly missed type of question, that you understand proportions when it relates to waves. So first of all, we don't have a squared proportion. So thank goodness for that, right? We only have direct or indirect proportion. The first thing I want to highlight, and this was actually from our first quiz, is velocity is actually independent of wavelength and frequency. The only thing the velocity is dependent on are 3 things. And there are 3 things that we noticed from our Slinky lab. Can anyone tell me what those 3 things are? What is my velocity dependent upon? And it has to do with the medium. Let me have Mason. Density. Adele? The type of material, but an aspect of that material itself. Colin? Tension. And what's the last one? And this one actually doesn't have to do with the material. Matt?
Wavelength?
Not the wavelength. Like I said, the wavelength might be part of the equation, but it's deceiving because the wavelength actually changes something else. What is it now? The type of wave, and I'm going to put longitudinal. That's the one that makes it go faster. And this is only for this. This applies to the material of the wave and the type of wave. Sound waves are a little different. Low density causes waves to travel faster, with the exception of sound. And like we saw in yesterday's video, if you have sound going through high density objects, or actually I did it with our music box guts, right? If it goes through a solid object, high density, it's going to move faster. But that's not what happened for our Slinky wave, or most types of waves. With that said, we've got 2 other variables here, wavelength and frequency. So what type of relationship do wavelength and frequency have? Is it direct? Is it indirect? If I want to increase frequency, knowing that velocity is not going to be affected, what is going to happen to my wavelength? It's going to decrease. That means that they are inversely proportional. Wavelength and frequency are inverses. As one goes up, the other goes down. And we're going to see that in our lab today. So like I said, a lot of the concepts that we're going to get from today's lab are also going to help you for your quiz. Any questions, comments, concerns?